know. For example, how do I undo that? Divide by 3. Now, what I'm doing then is multiplying by its inverse, right?
Yeah.
What's the inverse of 3?
1/3.
1/3. And what do you get for an answer? 3. Why is 1/3 the inverse of 3?
Because 3 is 3 over 1.
Because 3 is 3 over 1.
And the inverse is the opposite.
The inverse is the opposite.
Yep.
You do the reciprocal. More importantly, when you multiply things together by its inverse, what do you get? 1. Whenever you multiply something by its inverse, you get 1. Now, one of the things that you might not have remembered is how you can rewrite 1/3 via an exponent. Remember that?
Yeah.
How?
Why do the negative there?
Hold on a second here. Let's see if you remember this. How much is 3 cubed?
27.
Good. 3 squared.
9.
3 at the first power.
3.
3
3 to the 0. 3 to the negative 1. 1/3.
That's dirty.
What happens here is that negative 1 power relates to an inverse. So what you can do then is that you can take the same premise of solving an equation via inverses as you can with solving equations with matrices and their inverses. Now, as we get into the inverses of matrices, instead of, and I don't want you to write all this out, an inverse of a matrix, instead of 3 times 1/3 equals 1, an inverse of a matrix, excuse me, when you multiply those two values, the two matrices together, give you what's called the identity matrix. Now, in an identity matrix, you have 1s on the diagonals, and you'll have that many 1s depending upon how many rows and columns you have. These are all going to be square. So if it's a 2 by 2, you have just 2 1s. If it's a 3 by 3, you have 3 of them. Yeah.
That's kind of like a problem.
Right. Good idea. That's a very good way of looking at it. Okay. So what you're looking at here is we're getting to the point of being able to multiply things out to find out if they're inverses. But that just takes too long. On your calculator, there's a button. I bet you if you look really, really, really hard, you'll find a button that says x to the negative 1. What do you think that stands for? Inverse.
I'm looking hard.
Because here's what happens. If I had, remember how we've had matrix equations, we'd use capital letters, matrix A times x equals matrix B?
Yeah.
If I had matrix A times something equals matrix B, to undo multiplying by matrix A, you have to multiply by its inverse, right? So that means that the answer, this x, is always going to be the inverse of matrix A times matrix B. Now remember how we talked about before that the commutative property of multiplication doesn't hold for matrices. A times B, matrix A times B won't be the same thing as matrix B times matrix A. That doesn't hold true. So you do have to remember this thing here. Whatever one you're taking the inverse of, always has to go first on the other side. That's the only real rule of this. You have to make sure that you put the inverse first. If you don't, you're going to get the answer wrong. But like I said, where is this getting us? Well, we can take the following equation. And in our calculators, we all remember how to hit the alpha zoom, right? So, move this over here. If I do alpha zoom, I want to create a 2 by 2 for matrix A. You agree? Now, what this is actually asking me here is, matrix A is a 2 by 2, matrix B is a 2 by 2. What does X have to be in terms of rows and columns? It has to be a 2 by 2. Okay? It's going to be a 2 by 2. So what we do is we fill in the blanks. 4, -1, -3, and 1. And now we hit our new favorite button, inverse. And I have to multiply that to matrix B. Alpha, zoom, 2 by 2, 8, -5, -6, 3. There's my answer. What this is telling me is that what this is telling me right now.
Whoa.
Oh, you know I can do that?
No, I didn't.
Really? I was figuring you guys have seen that. What this is telling me is that if I take the original matrix and I multiply it by 2, -2, 0, -3, my answer is going to be matrix B. What I'm doing here is I'm solving what works out to be a one-step equation, 3x = 9, but I have to press a lot more buttons to solve it. That's all I'm doing here. I'm using this to set up and solve a very short equation. Your calculators are going to allow you to do this. I'm still wavering on the idea of having you crank these out by hand. I think I might not, depends on the day. We might have time where you might be able to do this. It's not very difficult. You can get some crummy looking fractions every once in a while, but it's not the world's worst thing. What's nice about being able to use inverses, as you'll find out here in a couple of minutes, is that you're going to be able to do so many different things with it. It's going to be able to set up and solve systems. Yes, those nice long 3x3 systems that you hated doing by hand, you don't really need to anymore. Because math just got easier. Interesting. Want to try another one?
Sure.
Same idea. I have two matrices. And I want to solve for x. Once again, in this instance here, I have a 2 by 2 times something to get another 2 by 2. What's that something going to be? Remember the pattern here? If you have a 2 by 2 times something to equal out a 2 by 2, these two numbers had to be identical, and then this one and this one was your result. Well, your result is 2 by 2, so that means this has to be a 2. And what's this number? So what is this? What is matrix X going to be?
A 2 by 2.
A 2 by 2. You're setting up to solve to figure out what that matrix is going to be. And we do that via the calculator. What's that? It is. It should be. And that's why I wanted you to show you that sometimes you're going to get funny looking numbers. Let me move this over so I can put it up on the screen. So alpha, zoom, 2 by 2. 5, -1, 8, 2. Inverse, alpha, zoom.
Oh, good grief.
Crummy looking stuff, right? Math, enter, enter. Not so crummy now, is it? Ooh. So should you ever give me decimals for answers? No, decimals are bad. Decimals are ugly.
So that's what x equals?
Yep. That's what the matrix you'd have to multiply it to. Remember, what you're doing here is you're figuring out what matrix would I have to multiply matrix A by to get matrix B. That's what you're solving for. Instead of it being 3x equals 9, where x was 3, I'm figuring out that, well, matrix blah, 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 blah times matrix blah, 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 blah equals matrix blah, 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 blah. Because I said blah 4 times each time, so we all need to support 2 by 2. Okay?
Hey.
Every once in a while, you have a decent idea. Matrix inverse operations work the same as regular two-step equations would. You follow the same order of operations. For example, if I have an equation like this, let's say it's 3x minus 1 is 6. What would you do first? You'd add the 1. And you get 3x equals 7, right?
Yeah.
And then what would you do?
You divide by 3.
Good. And then you would divide out by the 3, basically multiply by its inverse. Now, when you have a matrix equation that has multi-step, think of it along the exact same lines. If I'm looking at this here, matrix A matrix A times x minus matrix B equals matrix C. What would you have to do first?
Add the matrices.
Good. So in order to do this first, you have to add this whole matrix over. Now when you're adding matrices, what do you add together? Yeah, the equal spots. They're called entries. You add the entries together. So this is the subtraction, which means I have to just add all these over. So what's negative 1 and 4? 1 and 6?
7,
5 and 8?
13,
7 and 2?
9,
Now what do you do?
right.
Use your inverse.
Yeah, that's what
Okay. Now you set up and use your inverse. Okay. If this was an addition symbol between the two, what would you do to move that matrix over?
Subtract.
Biggest mistake you're going to make once again is what? Signs. You mess up signs. Yes, sir.
The biggest mistake I'll make is like doing that thing where you do 2 of them for multiplication by addition.
Oh, yeah.
Yeah.
Yep. So you hit your inverse buttons again to figure out what this value is going to give you. I'm just going to use my regular calculator because the one on the computer takes too long to type. All right. Let's see. So it's inverse of 4, negative 3, 6, negative 2. Did you get the following for your results?
Oh, yeah, you got it. Yes.
Did you get that?
Yeah.
Told you. Math gets easier eventually. I don't remember.
32.
Do this one.
Four by 4s.
You can do a whole bunch of stuff. But to be honest with you, when we start working with just matrix equations, you're going to start seeing stuff like this. But the other thing that we're going to be able to do is the following. What I'd like you to do real quick is, do you remember how to create a coefficient matrix?
Yeah.
Create a coefficient matrix for that system right there for a second. I want you to create a coefficient matrix and a solution matrix. You looked at me real fast. Remember, the solution matrix, in this case, remember what we did? We called this a column matrix for the solutions. Create a column matrix for that one real quick. All right. I'm going to show you a nice little trick.
like a solutions one too, is it?
Yeah, because when you do, you're gonna wind up with a solution matrix that's a column matrix. 2 rows, 1 column.
Like a solution, like just the solution.
Now, here's the thing. What I want you to think about here of what's going on. You have a 2 by 2 times something to equal a 2 by 1. The something matrix in the middle here, in order for your solution to have a 2 by 1, it has to have the 2 rows and a 1 column. That's why it creates that variable xy column. Now, once again, think about this in terms of an inverse. How do I get this xy column by itself? Well, what did I do? What did I do on the other ones? I multiplied by the inverse, right?
Yeah.
So in your calculator, if you take the inverse of matrix A times matrix B, it's going to equal that x column matrix. Now, matrix A is, once again, alpha zoom. It's a 2 by 2. -3, 4, 2, -1. Take the inverse. Matrix B, is it a 2 by 1 or a 1 by 2? 2 by 1, good.
This time you're just finding x.
I'm
not
finding that
creating a
column.
equation.
I'm going to show you real quick what you're finding here. So go back to your alpha zoom, and it's a 2 by 1 now. 5, -10. So in your calculator, in your calculator, you should have that set up. Because a 2 by 2 times a 2 by 1 is going to spit out a 2 by 1. What do you think that -7 and -4 represent?
X.
X and Y.
Oh, X and Y.
That just solved for another, it's another way to solve the system equation.
Oh,
Are you serious? That's
Uh-huh.
so easy.
I thought D was a 2 by 2.
Why is it
Oh.
so hard to some
Because I couldn't see it outside.
This
Oh.
is X, and that's Y. It's another way to solve systems by using inverse matrices.
Wow.
I gotta write this down.
Be helpful. Now, think about all the time that you guys had to waste doing all those 3 by 3s, and you're muttering bad words under your breath about me, my family. Think about how easy it is now. Well, thank you. I would say think about your assignment. Use an inverse matrix to solve this. I bet you anything, when you do this now, you don't even need to write down the problem. You go right to the inverse matrix, because what do you know? You know that if you take the inverse of the coefficient matrix, multiply it by the solutions, you're going to get X, Y, Z.
Oh, really?
Uh-huh.
Oh,
This is gonna be 3 by 3.
That's another way to solve systems. Alpha, zoom, 3 by 3. Coefficients, 2, 3, 1, 3, 3, 1, 2, 4, 1. Inverse,
So why do you put 3, 3?
because that's the second row, goes 3, 3, 1.
Supposed to be 3, 4.
And that goes 1, 1, 1.
I was in 4, 1.
3, 3, 1.
Oh, I was going down.
Yeah.
Oh.
Wait, you can put them any way, right?
No, you gotta keep them in order.
Wait,
What you're doing is you're creating a coefficient matrix.
Yeah. So the X's go down?
Yeah.
Okay.
Yep. X, Y, Z goes right on down the line.
Sure.
And the reason why that is because when you're doing with these inverses, remember I told you about the columns of ones?
Yeah.
X, Y, Z. What happens here, all the rest of the matrix becomes zeros except for that column. That's what you're solving for. You're finding the inverse that creates this to happen. Yes, sir. I don't know. Maybe.
Because I'm like, I'm
Matrix
just messing around and I have like 5
I don't know. You might be able to. Now, did you guys get for X, Y, Z respectively?
Wait, I don't know.
Yeah, don't say it.
Yes.
Yes.
Yeah.
You got it.
Yeah.
Because I'm a jerk.
So then that the whole 4x4, 5x5, we didn't have to work that out.
No. Why would you?
Oh, because you said we had to.
I didn't say you had to. I said you could.
Alright, so what y'all get? Okay.
Now, here's the thing. Obviously, this is a much simpler way to solve things, which is good because we have a couple of days to go back through the entire chapter and do every single word problem. Because now you're going to be able to set up and work through them.
Oh yeah, you see it?
Because now you know the easy way out. You don't have to work through all the difficult ways of setups. As long as you can extract the information to solve, done.
How about it?
Okay? What we're going to be able to do, and I think this might work out well, is we're going to use these inverse matrices today for a couple of sets of homework problems. Tomorrow we'll build it back in with all the word stuff. Friday we'll do some of the 2x2 inverse by hand. Monday we'll review prior to the 20 minutes that I'll give you guys for the by hand test portion. It might just be 4 questions. You will have to do a Kramer's rule 2x2. I won't make you do 3x3 by hand. Do a 2x2 Kramer's rule, and as far as the other ones, I'm not quite sure exactly. There'll be definitely a multiplication problem. I'm not sure what else I'm going to throw in there yet. And then the test part on Tuesday, we'll have, obviously the calculator is good to go, so you'll probably see a lot more word problems. But once you know how to pull up the information, it's a piece of cake.
What day is that?
Monday, Tuesday next week. Okay? So, any questions about what we've been looking at so far? Let me give you some problems. Section 4.4. Yeah. Let's get here. Section 4.4, I'd like you to do numbers 29, it's on 227. Numbers 29 through 32. Most people do very well on this test, so I hope you do. And then on 4.5 is on page 233. I believe it's 10 columns. Okay? I'll rewrite it up here.
Do you have a preparation of hand or calculator?
I want you to use the calculator on these things because I haven't shown you an inverse yet by hand.
Oh.
That's all we said to me.
Okay? Use your calculator on these things. Just be careful when you're setting up those equation stuff, not to accidentally flip a value. You will get crummy looking fractions. You will. It happens. Sometimes you will.
I hate
Yeah. What are you talking about?